This is a simplified drawing of an orifice tube air conditioning system in a vehicle. We have the compressor, the condenser, the metering device, in this case the orifice tube, the evaporator, and the accumulator. The compressor is the heart of the air conditioning system in our vehicle. It circulates the refrigerant throughout the system, but also builds pressure against the metering device to make the refrigerant cycle possible. The condenser is the component in the HVAC system that takes the high pressure vapor refrigerant and condenses it into a high pressure liquid refrigerant. The metering device, in this case an orifice tube, is the component that drops the pressure of the refrigerant in the system. So it's going to be coming from the condenser as a high pressure liquid and leaving the orifice tube or metering device as a low pressure liquid. The evaporator is what takes the low pressure liquid and vaporizes it back into a gas or a vapor. So we're going to have a low pressure liquid entering the evaporator and leaving the evaporator as a low pressure vapor. In an orifice tube system, we have an accumulator located right after the evaporator, ensuring any liquid refrigerant that may not have vaporized during the evaporation process does not get back to the compressor, causing catastrophic failure. The refrigerant cycle begins at the compressor, where low pressure vapor refrigerant coming from the evaporator is now squeezed in the compressor and pushed against the metering device, building high pressure in the system. It is a vapor. Any liquid getting in the compressor would be catastrophic because liquids do not compress compared to vapors, which can be compressed. The condenser is next in the cycle. It takes the high pressure, high heat quantity vapor refrigerant and condenses it into a liquid refrigerant using the relatively cool air coming from outside the vehicle through the vehicle's grill. As that relatively cool air comes through the condenser, it picks up the heat energy from the vapor refrigerant and turns it into a liquid refrigerant. The condensation process of the refrigerant is similar to what you would witness on a hot day and bringing a cold beverage out of your cooler or refrigerator. You see the condensation of the moisture from the air gathering on the outside of the can. What we're seeing in the refrigeration cycle is the refrigerant inside the tubes of the condenser is moving from a vapor to a liquid, and the heat that is pulled out of that refrigerant to do so is now picked up from the air coming through the condenser and dissipated outside the vehicle. The condensation process is critical to the success of the refrigeration cycle. Refrigeration requires mass quantities of heat to be removed from the refrigerant because we are trying to remove heat energy from the air going into the cabin. The change of state from vapor to liquid and vice versa transfers much more heat than if we were just circulating a liquid or a vapor medium throughout the lines. The next step in the refrigeration cycle is when the high pressure liquid coming from the condenser is metered through the metering device, whether it be a thermal expansion valve or an orifice tube, as it is in this case. The orifice tube or metering device takes the high pressure liquid and turns it into a low pressure liquid. Think of putting your thumb over the end of a garden hose and the mist that you see coming out of that. We've got a low pressure liquid coming out. The next step in the refrigeration cycle is the evaporator. The hot air that's outside of the car attempting to enter the cabin needs to be cooled off or heat quantity removed before it enters the car. This will displace the hot air that is inside the car and make you feel comfortable. So what happens is the low pressure liquid refrigerant enters the evaporator, and as the hot air from outside passes over it, it vaporizes it. It basically boils the refrigerant back into a vapor. So as the refrigerant leaves, ideally it is all a vapor. And it is transferred all of the heat from the outside air, or a large quantity of it, to the refrigerant as it goes back to the compressor. In an orifice tube system, since the metering device is fixed, meaning the size of the hole in the metering device does not change, it's possible that not all of the refrigerant boils off in the evaporator. If that is the case, any liquid refrigerant that is left over accumulates and is caught in the accumulator before it goes back to the compressor. At this point, the vapor refrigerant re-enters the compressor and the refrigerant cycle starts all over again. The success of an air conditioning system in a vehicle is dependent on removing heat energy from air entering the cabin and giving nice, cool, less hot air inside. What that requires is the air entering the cabin of the car is coming outside, and the heat energy is being removed by the evaporator. That heat energy is now transferred in this refrigerant, and then we are getting rid of that heat energy as the air from outside the car is now picking up the heat energy as it transfers into a liquid. The temperature of the air entering the cabin and the air entering the condenser is the same temperature. It's the outside air temperature. Pressure and temperature are directly related, meaning if you increase the pressure of a substance in a closed container, the temperature will increase. If you decrease the pressure in a closed container, the temperature will decrease. This also changes the properties of certain materials. So the refrigerant, we are able to increase the pressure and temperature, and it changes the boiling point to make it useful for what we want to do with it. So in this case, the compressor has raised the high pressure vapor refrigerant to 200 psi, approximately 130 degrees Fahrenheit. What this has done is it has raised the boiling point of refrigerant above the ambient temperature. So let's just say it's 80 degrees outside. So as the relatively cool 80 degree air passes across the condenser, the vapor refrigerant condenses because the heat energy is removed from the refrigerant. Now we are left with a liquid refrigerant. We still may transfer some of the heat energy from the liquid high pressure, high temperature to the air as well. And so we may see a drop of maybe 10 degrees across the condenser, but we still are at a high pressure, a relatively high pressure, and a relatively high temperature compared to the ambient air temp. What we have now managed to do is remove a lot of heat energy from the refrigerant, but we have actually not changed the sensible temperature of it very much. So we have much less heat quantity here than we did here, but our actual sensible temperature is not far away from each other. And that is because of the high pressure on this side of the refrigerant system. As refrigerant passes through the metering device, the pressure greatly drops. So we have moved from approximately 170 psi to 33 psi. That also changes greatly the sensible temperature. So going from 120 degrees to approximately 38 degrees. The thing to remember is the heat energy in the refrigerant did not change. The amount of pressure in the line has changed. So that also changes our boiling point of our refrigerant. It makes it more favorable for what we're trying to do in the evaporator. So as our liquid refrigerant enters the evaporator, it is a low pressure liquid. Now we are taking our relatively high air temperature from outside the car and blowing it across the evaporator. As we do so, the refrigerant boils. So the refrigerant is now boiling at 38 degrees and acquiring a large heat quantity. As it leaves the evaporator, it now is still low temperature as far as what you can feel, but it has a high heat quantity accumulated into the refrigerant. So now as the vapor refrigerant re-enters the compressor, the vapor is low pressure and it has already picked up lots of heat from the air before it got into the cabin. So even though it is low temperature and low pressure, it has a lot of heat energy. Once we compress it at the compressor, now we have a high pressure, high temperature refrigerant with a lot of heat energy still in it. And that's why when we bring it back over here, the ambient air pulls the heat energy as the refrigerant is condensed and draws it out and dumps it outside the car. So that is the refrigerant cycle and how it actually works for us. The low pressure, low temperature vapor coming out of the evaporator actually has a high amount of heat energy because it pulled it out of the ambient air going into the cabin. So now when we compress it, we are skewing the boiling point above ambient temperature, so that way when the relatively cool air comes through, it condenses it back into a liquid. Now all the heat energy that was here, that was going to go into the cabin, is now here and going outside the vehicle and makes us comfortable. Now we can take our low heat energy liquid and turn it into a low pressure, low heat energy liquid and pick it up all over again. The success of the refrigeration cycle depends on the ability for us to take heat energy before it enters the cabin and transfer it through the refrigerant and dump it outside the car. The way we do that is by skewing the pressures in the AC system to change the boiling point of the refrigerant to do what we want it to do. Heat transfers from hot to cold or hot to less hot. So what we are doing here is taking our hot to less hot air and it dumps it outside the car. Same way here. We are taking our hot air and dumping it to our less hot refrigerant. The greater the temperature differential between the mediums, the faster and more efficient the heat transfer is.
Please leave your questions in the comment section, and don't forget to like and subscribe to the channel. Thanks for watching.